So thank you all for being here and participating today. From a Codurance standpoint, my name's Jack. I'm from Codurance, and we like to get involved in these initiatives because we like to give back to the community. It's definitely part of our DNA. Our mission at Codurance is to promote good practices and quality standards in the software industry. Our roots are in the London software craftsmanship community, and we take great pride in continuing to contribute to the software development community. And today we're delighted to introduce Elvis Saravia. Elvis is an educator and independent research scientist, deeply interested in machine learning, NLP, and information retrieval. Some topics of interest include, but are not limited to, information retrieval, data analysis, transfer learning, emotional recognition, sentiment analysis, intent discovery, language modeling, AI bias and ethics, conversational AI, social computing, and computational health. He's also the founder and editor of Outlier.ai, a popular publication that aims to communicate about the latest AI trends, technologies, research, and perspectives. He is also education architect at Elastic.
Can you hear me? Yes? Okay, great. So I'm going to start off now. So hi, everyone. First of all, my name is Elvis. Thank you very much for joining us today. I'm very happy for the invitation. I'm happy to do this presentation. I've done it for some time now. And I have added a few things because obviously things at Elasticsearch and Elastic, the company, keeps moving really fast. So one of my jobs is to keep up to date with things that are happening, particularly when it deals with machine learning, because that's kind of one of my interests. And so I'm very happy to share and ask any questions that you have about the Elastic Stack, and I'll take those towards the end. So let me just share my slides now. Okay. Hopefully this works. Okay. So can you see a slide? Yes. Yes. Okay, perfect. So what I usually do here is I will, disable the video because the video is kind of distracting when I'm presenting. So typically what I do is I just stop the video on my end, so you won't be able to see me, but you should be able to hear me. Great. So this talk is more about machine learning in the Elastic Stack, right? So I'm going to focus on that component of the stack. Obviously, Elastic Stack, it's made up of different components. For some of you that are familiar already with the stack, there are a lot of different tools and solutions that are available in the stack, and they allow you to do things like collecting data, transforming data, processing data, storing the data, and eventually analyzing. So I'm going to discuss the data journey itself, and how machine learning is related here and how it applies in the context of the Elastic Stack. So my name is Elvis, as I said. I am actually based in Amsterdam at the moment, but I'm originally from Belize. So this is a very small country, in Central America. So I've been traveling around the world before coming here to Amsterdam. I was actually doing a PhD in Taiwan, and just doing a lot of data analysis, data mining, and machine learning and natural language processing. And my whole thesis was around natural language processing. So I have quite some experience with this particular domain and field. So I'm an education architect as well at Elastic. And I'm an independent research scientist, meaning that I care about progressing the science of machine learning and publishing papers and helping the community and do a lot of advocacy work and this type of thing. Okay, so this is the Elastic Stack. This is what I was going to talk about. So if you notice here, right, this is very typical of a presentation from someone from Elastic. Yes, this is basically how we kind of pitch the Elastic Stack. So here you would see at the bottom there is kind of like an ingest layer.
Please, could you mute Theodore, Alberto, and Guillermo? Could you mute it, please?
I think there should be an option to kind of mute people coming in?
Yeah.
Yeah. Okay.
On.
Great. All right. So as I was saying, there are different components in the stack. So the first part, which is the bottom part, is the ingest layer, right? So here we care about collecting the data and transforming the data before actually storing it. So this layer is what we call the ingest layer, and it gives you a lot of like tools and processors and different transformation tools to transform the data and do any kind of transformation of data that you want. Now, we have two solutions, and the two solutions obviously have their benefits and disadvantages, but it's common to see either one in a data collection pipeline, especially for those companies using the Elastic Stack. So Logstash is more heavy processing, so reading data from multiple databases, for instance, and it offers you some filters and processors to transform the data and actually do some kind of extraction on the data in an automated way. So you only need to configure a script, and once you have that script well configured, you kind of say, okay, I'm pointing this data to, say, an Elasticsearch instance that's in charge of actually storing the data. Beats is really similar. It's more like very lightweight kind of data shipper, right? So we have Beats, for instance, to collect data that's coming from a log file. So for instance, you have a web server that's generating some log file, and we can read that log file in an efficient way and kind of process it and essentially send it to Elasticsearch, which is going to be our storage engine here. So Elasticsearch, which is the middle component, is more like for analysis, doing all types of search, doing aggregations on your data, transforming your data, and also some really, really cool types of processing that you can do on your data. Now, Elasticsearch is very robust. It's almost we refer to it as a near real time. It's very scalable as well. So it gives you a way to easily scale as more data is coming in to your storage engine. Now, it could also be distributed, right? We offer it as well in a cloud solution. So if you want to put data on your cloud, in the cloud, it also comes like that. But you can also install it on premise, right? So download the package. It's open source. You can download and store your data however you want. Now with Kibana, which is at the top, we refer to this as the window to the stack. So here is where we kind of want to analyze the data, right? Visualize it. So it offers you ways to create all sorts of visualizations, advanced visualizations for all sorts of different types of data as well. So if you have like time series data, which are like logs, it gives you really nice tools to visualize that data efficiently and be able to pick up insights from your data. It also serves as a management tool, meaning you could actually manage, you can manage your Elasticsearch instances, for instance. It gives you even API tools, like an API tool, and we'll look at that today, how to explore the data that's stored in Elasticsearch. So all of these components that you see here are quite connected, and this is referred to as Elastic Stack. So we have different solutions. These are the different solutions, and on top of it, we have also our different use cases that we support. So we support like search, observe, and also some security tools as well. And here we're mostly going to focus on machine learning. So we're going to first talk about how to transform data, prepare the data before you actually apply some kind of machine learning job on this. So that's what I'm going to focus on today, and I'm going to show you like how we are kind of improving the UI in some sense, in a way that you don't even need to like type a line of code and be able to actually pick up those insights from your data. Because companies, they have a lot of data, but they haven't found ways or to create or establish pipelines, something that scales into production, such that you can pick up insights in an automated way. That's ideally what you would want with your data, because you have a lot of data sitting there and you're not really taking action on it, or you're not making decisions. And that's something that's unfortunate, and that's why we're spending a lot of effort to build these tools and give you these tools and make them as accessible as possible. Now, machine learning in the Elastic Stack, right? So as I said, you can set up an Elasticsearch cluster. So these are the kind of the nodes where you store the data in a scalable way, and eventually you have like a different node in that cluster that is able to support machine learning capabilities. This is where you're gonna set up your jobs, your machine learning jobs. And by the way, as I say, set up jobs, but in a way that's it's not difficult, right? So you will use basically UIs and interfaces to actually do this. And there are a couple of steps here. So the data visualizer, notice these steps that you see here are very like generic, right? You see them a lot in data science. So first you want to explore data, so data visualization. So we offer a data visualizer, and then there I'll show you that as well. So what's after that? Then well, maybe you want to, after you have an idea of your data, then maybe you want to transform, apply some kind of transformations. And so within Elasticsearch, you can actually perform some transformations, and I'll show you the tool you can use for that. But you can also do transformations before the data reaches your Elasticsearch cluster, right? So before that, and that's where I was discussing like Logstash and these different tools. And then there's modeling as well. So modeling is more like setting up your machine learning jobs, and eventually you want to evaluate them as well. So we have some new APIs to evaluate your machine learning jobs and how they're performing and how they are generalizing, right? So that's something you're really interested in as you design a system to perform some kind of machine learning operation. Okay, then visualization, of course, is kind of I think this is really great. This is where like Kibana really shines, because it offers you like really advanced visualizations to be able to visualize your results, right? And once the data has been labeled by this machine learning job, you can actually use all sorts of visualizations to get an idea on what the model is doing good or what the model is doing bad, and how to actually improve that model. So I think the pipeline here is really very generic, but we support that with the Elastic Stack. And it just keeps getting better because we are constantly adding more and more types of machine learning algorithms available to the users. So notice here in the picture on the slide, actually have a figure, say supervised ML and unsupervised ML. So what's the difference between these two? So for unsupervised, it means that you don't really have labels. So right, so for this, it would be something like trying to train an algorithm to learn like the model of the data, right? So the patterns of the data. And once you have that patterns, well, now you can actually test it against an incoming, for instance, like an incoming tweet or an incoming log. And then you can actually say whether this log, depending on how the rest of the data is behaving, like the historical data, so it decides whether this is an outlier or not. Okay, so that's the kind of the job of this outlier detection algorithm. And it's classified as an unsupervised because it doesn't include labels. But on the left-hand side, we have the supervised techniques, which are classification, many different kind of classification algorithms. And then there's the regression analysis. And the difference between the two here is that in the classification, what we're interested in is classify, say something like tweets, into positive and negative labels. But this assumes, because it's supervised, it assumes that you have the labels. So you have the positive and the negative labels. And also for regression, it's more like, of course, if you want to predict, say, housing price, so this is a continuous value, and you want to predict that sort of thing. So depending on how the data looks, you're going to use different algorithms. So let's get into the machine learning modeling. So by the way, it's not a lot of slides, just a couple of slides here, and then I'm going to move into more like a visual, kind of interactive demonstration to show you some of the features. But here's just an overview. So the data frame analytics, right, is a concept actually in Elastic Stack. It's recently was introduced. Actually, I think it's still in the experimental phase. So it offers you a kind of like a pipeline. You can think of this as like AutoML, where you don't really need to worry about what model to select. None of that stuff. That stuff is automated for you. So we have algorithms to actually do that for you behind the scenes. So it takes care of the analysis. It takes care of loading the data to the algorithm. Then the algorithm actually takes the data, do whatever transformation it needs to do, apply the labeling that it needs to do. If in this case it's a classification task, apply the label, and then eventually write the result. So that's kind of what the process looks like. Notice here in the beginning, I have what's called a reindexing. Well, why do I need a reindexing here? Well, you should assume that when you apply this data frame analytics, what you're applying it on is something that exists already, but you don't want to touch that original data, right? The raw data. So you could have cases like this, and so what you want maybe is to take this data and then just reindexing as you start to do some experimenting with it. So this is just a way to actually protect you from touching that original data, which could be catastrophic for you. So that's already built in, and it supports different types of modeling. and you can evaluate any of these ones that you see here on the screen. So outlier detection, regression analysis, and classification. So classification could either be binary or it could be multiple, right, multi-label classification as well, where you have different labels, multiple labels for a particular text or something like that. So a little bit on outlier detection. So outlier detection, as I said, the idea is to have this kind of like statistical approach to build a pattern or build a model of the data, right? So it's kind of predicting this kind of like pattern in the data, right? And once it knows the pattern of the data, anything that comes in the future, it is able to know whether this is actually meeting the model of the data or if it deviates from the model of the data. So if it deviates, like as you see in the figure, right? Maybe it's just a really, really high value on a Sunday, for instance. If you have like an e-commerce shop, we tend to make 100, sales on a Sunday, but eventually we see, or at some point we're going to see 1 million sales or something like that. That's an exaggerated number, and that's not common. So that could be identified as an outlier. And we'll talk about it when I kind of show some examples, some more later on. And this is based on an ensemble. So it's an ensemble of techniques. So they're more like distance and density based. You can read more on our documentation. I won't go into too much details here, but it's an ensemble method, meaning that it ensures that it always capture the best model, okay, out of a series of models. And then, of course, the applications could be like bank fraud, threat detection, for security analytics, and then so even for diagnosis as well could be really useful. That's outlier detection. And classification is the other problem. That's the one I will talk about and give an example. The idea is to have an algorithm, train an algorithm to be able to predict, right, a category or class of a given data point in a data set. So if you have a collection of tweets, right, from just the web, you have crawled this and you want to categorize each tweets into positive or negative sentiment. So that's basically what you want to predict. That's your objective. So you kind of train an algorithm to do that. And when I say training an algorithm in the Elastic Stack, you're not really training the algorithm yourself. Everything is done for you automatically, right, using some kind of AutoML. And for this, under the hood, boosted tree regression models are being used here. Again, it's an example of these. And just to make sure that we have the best model and the best predictions. So it requires some feature variable. I'll talk about that later on, and some dependent variables. So dependent variables is the category class we want to classify, and feature variables are our features, right? Features that we're going to use to make some kind of prediction. And I'm going to show you how to do this later in the demo. So some applications: detecting cancer, classifying music or text, and also doing some kind of prediction of loan risk. So this has so many different applications, and that's the reason why we wanted to support this. Especially the case where you have multiple labels, which is now something you can do in Elasticsearch. So that's it for the overview. It's just an overview of the things that I will discuss in the demo. I wanted today to spend more time on the demo. So if there's any questions now, I'll take them. But maybe you can wait on your questions after I do the demo. That'll be fine as well. So any questions so far? Any questions before I move on?
No questions at the chat. There's not questions.
Okay, excellent. So I guess the questions will come when I do the demonstration, I guess. That's where all the action is going to happen. Okay, just a few references there as well that you can look at, and it gives you some kind of like webinars and documentations and how to use the APIs if you're into that stuff. And just a whole bunch of things that are useful to get started with machine learning. All right, so I'm going to move on to the demo. I think this is going to be really interesting to show because there are a lot of new things that are happening. And so the first thing I want to do before I actually talk about, first of all, can you see my screen still?
Yes.
Yes.
Yeah.
Perfect.
Yes.
Great. Excellent. All right, so the version of the Elastic Stack that I'm using, because that's the question that comes often a lot, because we're kind of constantly, iterating, and we have so many new versions now. I can't even keep up with the new versions, but like 7.6 is the one we're using here, right? So if you use a newer version like 7.8, it's going to look a little bit different already. So a lot of changes are happening. So one of the things when you enter Kibana is our visualization tool, but Kibana has ways to manage, like machine learning jobs and these different things in the stack. So that's why it's quite powerful. And typically what we do and recommend is to always start by clicking the Kibana button over here. It's kind of hidden, there's no kind of messaging here that says go click there. But if you are starting with Kibana, always click on that one. And there's so many different use cases, right? Like APM, logs, metrics, and there are a whole different cards that you can use here to follow some steps and to support different use cases. So if you have a use case where you want to visualize maps, you can always go here. If you're into security analytics, you can go here. You have a use case to collect metrics, do machine learning, you have graph data. So all these different use cases here. And what I like about this interface, and at least this part of Kibana, is that you can always go here to add sample data, and you can start to play around with a data set. Because it may be the case that you just want to quickly play with it and see if this is going to serve the use case. So it's always good. We have 3 different use cases here. So we have like logs, right? So sample web logs from some kind of Apache server, something like that. Then we also have like flights data collecting from, let's say, something like airline or something like that. There is like e-commerce. These are more like transactions. These are like static data sets, right? They don't change that much. They're just like logging different transactions. So you have all these different use cases. Now, I have actually added ahead of time. So you can see here it's installed because it's already added. And actually, when you click the button here, it gives you a couple of options. So you can always go to dashboard or graph or maps, and depending on what kind of data you have there and what's supported, it will give you some options. Now, you can add data by just click on the button. This one I won't add because I won't need it here, but these are the ones that I'll use in this demo. So you also have things like this. If you go and you want to have like a use case where you have like S3 buckets or something like that, and you want to track the logs, you can always go to that and follow the steps. They're very, very easy to follow. Now I'm going to move ahead and try to look at what kind of data do I have here. So the first step is to always explore the data. So if I click on the button here, I can always go on the dashboard, but dashboard assumes that I already know how the data looks and I want to create some visualizations. But I'm not interested in that. What I'm interested in is to do a discover and examine my data. So I could do it in multiple ways. So I can always go to this button here. Actually, let me just pull this collapse option here and go to discover. And so here we have the data sets that we have actually indexed, already. So these are just sample data sets. So these 2 are the ones I just pulled. And I have others as well because I was doing something with this particular node, but that's not important here. So for this flights data, if you want to understand it, right, you go here and then you look at how the documents look. Because basically Elasticsearch is just going to store documents, right? And it has a lot of information about a particular document. So if this was, in this case, a flight, it tells you what the destination was, right? It tells you, should have also the origin point. It tells you like how much distance or miles in terms of miles. So all sorts of information for different flights. So that's something I'm going to use later on. And then the other one I'm going to use is the e-commerce. These are just e-commerce transactions. Notice that when I actually click on that one, there's nothing that's going to come out here. Why? Because one thing you will learn, and you will learn this the hard way in Kibana, is that you always have to think of data as sort of like a time series, right? So it has some time element to it. And we always need to pay attention to that because we're exploring it, but somehow we don't have data for the last 15 minutes. So maybe this data was from yesterday. And because this is a static data set, as I said, so maybe it's from last week. It could even be from last year. So what I'm going to do here is to check. So I can always go here and change it to this one, this option, and then just update it. So notice how the UI has different elements, right? So you have like a search component where I can just search this data set. I could do filter by the time. And so I could actually go to the available fields of this particular data set. So you can see here, even it has like an icon, display the type. And somehow, maybe this one looks like it's really, really messy and I cannot really understand what's going on. You can always go to this side, right, the left side. And maybe, let me just make this widen this a little bit. So let's say I want to know the customer full name. So I select that and notice now the view changes, right? So it's only the fields that I have selected. So these fields here. I can always remove it and it goes back to the original view. So that's really helpful when you're exploring data because maybe sometimes you don't want to look at everything. You just want to look at some particular fields. So again, I haven't used any line of code. I'm just interacting with my data, exploring my data, understanding it before I even start to do visualizations with it, or apply some kind of machine learning to automate this analysis and pick up insights from my data. So that's a good first step. I'm not going to focus too much on that here because I'm just going to move on to the machine learning part, which is what I was supposed to talk anyways. But I always like to do this sort of introduction for people that haven't used the stack before. All right, so we have different options here: visualize, dashboards. We have like Canvas as well to create really rich infographics. We have a maps feature, machine learning right there. That's the one we're going to use. So we have all the different use cases. So like if you're collecting metrics from your servers or your services, logs as well. So logs generated from something like an Apache server, and APM use cases are if you're kind of interested in monitoring your applications. That's actually really useful as well. And we have SIM, which is more for security analytics. And if you have graph data as well. And then there's this really interesting developer tools. I'm just going to jump straight into developer tools, because if you're a developer, you will love this stuff. So here on the left-hand side, we have, this is how we're going to, because at the end, one thing I didn't mention is that Elasticsearch, the component that's actually storing the data, you can interact with it via REST APIs. So it has some APIs that you can, some endpoints that you can interact with to actually examine the data as well. So you can do it through the Discover, but you can also do it if you're a developer, a hardcore developer. This tool you will love. So for instance, remember the Kibana sample data e-commerce, that's my data set, right? And it has a bunch of fields. And if I want to know like what sort of documents exist there, I can actually go here and just select this, and it tells you, it gives you a JSON, right? So this is the JSON, this is the raw documents that it's sending back based on the search that you have done here and the endpoints that you have selected. And so it's going to give you the information. If you're building a web application, you can think of this as well. Now, this is the data that I will interact with and eventually do something with it, right? Like do a visualization or something like that. So you can see here that it has like hits. Now, hits refer to what Elasticsearch is sending back, right? Whatever matched this search. In this case, I'm not being specific with my search. I'm just searching in general. So it's just going to send maybe the 10 latest hits. So if you notice, if you know JSON, these are just like key value pairs, but the most important part here is this hits. So let's see. So let's see how much it sent back. So, you have 10 documents that were sent back, right? So it's just the top 10 latest documents maybe here. And each document contains the same information as I showed you in the Discover. So these are just different ways to view the data and examine. It all depends on the level of skill you have. I always say start with the Discover, but you have advanced ways to do that as well. Now, the reason I show you the developer tool, and I didn't want to emphasize too much in this presentation, this part, because obviously this is for advanced users, right? But the great thing about it is that if you want to get all the capabilities of Elasticsearch, so for instance, like the ML capabilities, you would have to use the APIs. There's no way to run away from this. And if you look at our documentation, most of our documentation is referring to APIs anyways. So you always have to get used to it. We have really nice documentation with a lot of examples. So don't be afraid to get familiar with it. It's really powerful once you start to use Elasticsearch. And so I have a couple of jobs that I have set up here ahead of time, right? But this is just to show you, how much code I need to know, right? So how much code I need to know to actually set up an outlier detection job and a classification detection job. And actually, before I set up my machine learning job, I need to transform the data as well, because the data could come in a format which is not really useful for my machine learning job, or my machine learning job is not compatible with that. So in that case, I really need to do some transformation with data. And so look at it. It has like 250 lines here, and I really need to know the syntax. So there's a huge learning curve here. It's very steep, and you need time to actually get this done. In other talks, I would usually go to this, but it depends of course, on the audience. But what I promised for this particular meetup, I wanted to focus more on the UI and how easy this can be without touching a line of code. So I'm going to go straight into the machine learning feature, which is this one. So it's like a little brain icon. Okay, so it's loading. And notice this one is actually on the cloud. So I'm actually running everything on the cloud right now. It's very easy to set up. So I always encourage that if you want to play around with it, there's actually trial versions, but it's really powerful. I always use this one now. I don't install it locally because this is just so great. I save myself a lot of time. All right, so when you go to machine learning, there are a couple of options. So there's the data visualizer, data frame analytics, anomaly detection. So the data visualizer, what is this? This is the first option I want to show. This is great because if you're a statistician, you're really curious about the distribution of your data, distribution of certain field values. These are the things that you're asking yourself when you're exploring and examining your data. And that's something you should generally practice. So here I'm going to look at like e-commerce orders. No, sorry, this is not the one. So these are my indices, and what I want to look at is maybe say like the e-commerce one. So once you click on that index, right? Index are like, think of them as tables. They contain different records. And so you can see here, you can get an idea of the distribution of certain field values. So let's see, let's look at one. If you have like a discount, this one is not a good example. Let's see, so price, for instance, right? So what's like the maximum price, median price, minimum price? And this can already tell you a little bit about your data, right? So that's that type of statistics maybe could be useful for you. What is per data? So we have like total price. You can see here is a median, a minimum, and a max as well. And you can do that as well for different fields. So for here is a categorical field. Elasticsearch can guess, right? It places guessing mechanism, and it has this guessing mechanism that kind of figures out, well, this is a category, and these are the category values, categorical values here for this particular field, and so on and so forth. So for all the different fields. So that's great. It's really good to have this one and be able to know more about your data. Now, the next step, once you understand what your data looks like, what your field values are, what's the distribution of your data, now you're ready to actually set up a machine learning job. So you go to Overview, and there's some like information about documentation. Usually you would start here, but we don't have time for that. So what we're gonna do is, the first thing I want to do is, before I set up a machine learning job, is to actually do some transformation on one of my data sets. The reason why is because I want to do outlier detection, and outlier detection is actually more like behavior analytics, meaning that it's going to perform, so I'm going to perform some analysis on entities. What does this mean? So the thing is, when you're collecting data, right, your data could come in a format. So for instance, it could come in an event-centric way. Event-centric way means that, for instance, you're logging, every click on your website. That's event-centric. It's always going to be event-centric, as those logs will come in that format. But let's say from these like logs that you're picking up, you have information about user, you have information about a country, you have information about regions, you have all this sort of like entity type information, and you want to do the analysis on that entity information rather than the whole event itself. So how do you do this? Well, what you typically do is you use a Python, for instance, use Python programming language, and you create your script, you transform your data, and then eventually you store it in the right format. So you have to do all this really like dirty process, really tedious process, and then eventually you kind of spending a lot of time on this. So we created a tool called Elasticsearch Transforms, which allows you to do that within Elastic. So once you have your data stored, all you need to do is just basically do some transformation in your data to the format that you want it. So as I said, if we have, in the example of transactions, so if we have many transactions, or we're logging the transactions, these are actually event-centric. Why? Because a user can actually have 100 transactions, and we will record all the 100 transactions, right? So all of them will be recorded. But we want to do the analysis at the user level, which means we have to do some transformation. So what we want is we want a representation of this data that only includes one line, one record for each one of our users. So we don't want to have that redundancy. And we also want to aggregate also, we want to aggregate some information about this user. So it could be the case that I want to look at total sales, for instance. And the only way to do this is by doing an aggregation. So aggregate all the transactions related to this user and pick up that final value that I want. And then I can do some outlier, really nice outlier analysis on this one. Okay, so let's look at that. I will take a look at the example. So I'm going to create a transform, and I'm going to look at the data e-commerce. That's the one I'm interested in. And so the neat thing about this is once you go in here, right, it also offers you a guide. So notice that I say that we have transactions. So for instance, Robert here, Hodges, could actually have 100 transactions here, but there's no way to tell actually because of the data. It's just displaying a couple of data points. But you should expect many different transactions from all these different users. So what I want to do is to actually capture this customer, capture the customer full name, and then all the transactions aggregated already. So that's what I want to do, and that's what I use transform for. So let me see how I do that. So I can go here, I can select what I want to group by, So as I said, I want to group by customer full name. So I can always go to customer full name, so which is this one. Okay. So notice that when I was typing, it's actually selecting for me already, depending on the values of that field. It's going to select what type of aggregation I need to perform. Because it could be like values could be text, or values could be, you know, actual numbers. So it totally depends on the type, the value type. It's going to, you know, use a different aggregation. So that's done for you automatically. So you don't really need to worry with that. So here's the example I was saying. So this one is a terms aggregation, data histogram. It all depends on the values, okay, of that field. So what I want to do is, so I did a grouping by customer, and then eventually I want to do some aggregations. And the results of the aggregations is what I'm going to use eventually to feed the model those features. So for instance, for customers, I want to know if there's some outliers based on some fields. So transactions, maybe something like that. So I'm going to select some of those. So for instance, I think I have a product base price. So I even have a product base price here, but that's not the one I'm interested in. Let me see. So let's see. All right, so tax amount could be interesting to look at. So I could always look at the tax amount, okay? So I want the value for it, so I can always select this one. There are other ones that you can use, but this is the one I'm gonna use here. And so as I select, it's gonna tell me, right, it's gonna tell me for each one of the users, it's gonna tell me how many transactions. So we have went from event-centric data to more entity-centric data, which is gonna be just one line for each one of the customers, because that's what I'm grouping by, right? So once I have that information and I collect my features, I'm basically building these features, and these are the features I'm going to use to feed the outlier detection algorithm. So that's a very important step. So I've done it ahead of time, and I'm just going to show you what that looks like. So let me see, I've selected a couple of fields actually to do that. And so I can go here, let me see which one did I think it was this one, e-commerce customer sales. And so these are the ones that I selected. So I selected, of course, the customer first name, it should have been full name, but it doesn't matter here. So the order ID, which is how many transactions, okay? How many unique transactions, and how much, the quantity of the products, of course, here. And also the taxable price, what's the total price as well. So these are just some of my fields that some of the aggregated fields that I selected to do this outlier detection. So now when it's time to run the algorithm, I know what my data looks like. It looks good, so I'm ready to test this out. So now I go into machine learning, and then what I do is I create a job. So I can create a job from here, or I go directly to data frame analytics. So I'm going to go here directly, because notice here it says create your first anomaly detection job. I'm not interested in anomaly detection, but that's the main use case we have. That's why we have this option directly here. So what you will go is go to data frame analytics, and there you have different options for different types of machine learning jobs you can set up. So you can always go here, create analytics job, and then, so these are the ones I've done already ahead of time. But so here we have the options. So I have outlier detection, regression, and classification. So if I select outlier detection and just give it a name, right? You can give it any name you want. So in this case, I want to know like transactions, or maybe transaction outliers. Actually, I could just customer transaction outliers. I always like to name my things properly. And then give it a description if you like. If you're setting up a lot of these that have very similar names, it's always nice to have a description. And then choose your source index. So source index is obviously what has the data so far. So in this case, it's going to be, remember, it's going to be this one, right? So this is the one I have already. So this one has the transformed data already. That's the one I just recently showed you in the Discover tool. So once I have that there, I could always select a destination index. So what is this destination index? So destination index, this is what I was saying. So when you're setting up a machine learning job, you typically don't want to touch the original data, right? Don't want to touch the raw data, because sometimes you're applying this machine learning job on maybe a portion of the data, because you just want to know, like, quickly, what kind of results you're getting. So typically you don't want to touch that, because you can always mess it up. So and there's no way to go back. So I will set up a destination index as best practice. That's why the option is there. So let me just select here. So it's going to be So I think in the example, I selected e-commerce outliers. So I'm going to select e-commerce outliers 2. I think that's okay. And then here you have an option to exclude fields. So the other thing, as I said, this is more like AutoML because it's gonna select the fields that are appropriate for this. But because we have selected e-commerce customer sales, which this index only contains 3 fields, remember, 3 fields. So in this case, I don't really need to exclude fields. But if it could be the case that you actually had data in the right format, you did all the hard work already before you index this data into Elasticsearch, and in that case, right, you may want to exclude fields because it could be the case that your data actually has a lot more fields. And those fields are not really useful for the job that you want to perform here. So you can always go here and you can exclude fields. But here I'm not going to exclude them because I want to use 2 of them. Okay, so then I can just just create the job. This memory stuff you can read on documentation. Actually, there's some recommendations on memory limit. I'm not going to discuss that here. So I want to create that job, and I think it's ready to go. So I'm going to create start, and I think that's good to go. So I'm going to close this one. And notice here it's analyzing, right? So it was super quick. So here it is. I think that sorry, that's the one. Where's the one that I just did? Let me just refresh this. So that's the one I did, right? So it's the customer transaction outliers, which is this job here, and I can always view. So you can always take a view of what's going on. So this is like the amazing thing here, because I actually went from transforming the data, right? So went from visualizing the data, exploring the data, then I actually transformed the data because I needed to have it in a specific format. Then I made sure that data is in the right format. Then I actually went to machine learning jobs to create some kind of machine learning job on top of this data. And in this case, outlier detection, and then eventually I have the analysis itself, so the final results. So here you can see that it's giving me what the outliers are. So in this case, it looks like for this particular user, Wagdi, I think it's called, I don't know the actual name, but so this one has looks like it has a very, actually that's not the one, but Elisa is the one that has like the top outlier score. Actually, it should be Wagdi, but the problem is that I actually have first name. It should have been full name. If it's, it could be the case that Wagdi is actually a common name, right? Or it could be the case also that there was a first name and the degradation was completely off. So in reality, I should have had this particular user with a high outlier, but in this case, I noticed there was a change because I didn't actually transform the data properly. So in this example, but these are the mistakes that you tend to do, and you have to go back and fix it. All right, so this one has a high outlier ML score, and if you have a high outlier ML score, so what you want is to figure out why that's the case. So this table shows you the results, right? The actual results for this particular user and transaction. So in this case, there was this quantity, and there was like this taxable price. So these are actually actual values for that particular record here, which is this user. And you have this really interesting thing, which is the feature influence score. It tells you more. So if you want to interpret these results, what you do is you look at the values. So this one has a really high, this particular feature is very important. So notice like most of it is shaded around here. That means these are the ones that are important when this particular outlier score was predicted. So these are the ones that are mostly influential here, or mostly influencing this result. So that's how you interpret it. So that's the outlier detection. You can do a lot of things with this. You can actually visualize it using some kind of scatter plot and look at the actual points. The points should actually be really off, at least for those outliers. So you can visualize it in many ways. Maybe this is not the best visualization, but this one gives you already like what features are influencing the particular outlier score. And you can always like filter it if you only want to focus on, say, outlier scores above a particular range. You can always filter it here doing the search. So this is all experimental, right? And this is going to keep improving based on the community response and feedback. So I'm going to go now into the next example. So that example will be the classification. So I've done outlier detection. Now I want to do classification. So let's create a job, another job here. It's going to be classification. Then I'm going to give it an ID. So here I'm going to say classification job. So I have one already, so I will name this 2. And here I'm going to select the source index. So this one is going to be on flights. So I want to know, like, I want to classify flights, whether there's potential to be a delay or not, right? So I want to make sure this algorithm is able to predict whether it's going to be, this particular flight is going to delay or not. So that's the objective here. So the delay field is actually included in this, so that we have those labels, and that's going to be our dependent variable. So it's going to be what we want to predict. And the destination index, of course, I can select any destination index I want. So in this case, I'm going to do a classification of delays, flight delays. Okay, so I'm going to give it that name. And then the dependent variable, which is what we want to predict, is going to be in this case. So let's see. So flight delay, right? So flight delay is the one I'm interested in. I know this ahead of time, but you actually needed to explore the data to actually do this. And here it shows like what is the training percentage that I want to use, right? So if you want to use say 80%, or if you want to use your standard, like if you want to reduce the amount of time this particular job takes, maybe you want to reduce this, and this will ensure that it's going to only select 11% out of the original data, right? It's not going to select everything. So it totally depends on the size of the data. The bigger this is, obviously, the more compute it will need and the longer it will take. So here I want to exclude some fields. So there are actually some fields that will create some biased results in this particular analysis. And so those are the ones that you should be careful of, okay? Because they actually explain the, so they're almost identical to the flight delay, and that's something we want to exclude. Those fields we want to exclude. So that's another thing that we need to pay attention to as well. So I have done this ahead of time. I actually don't remember the fields themselves, but I've done this ahead of time and actually created so the flight delay classification, which is this one here at the bottom. So I will select this one. Let me see, view. Oh, sorry, that's not the one. So we have another one here. Let me check. Okay, so this one here at the top. So I selected the wrong one. Okay, so this one, notice I selected all the fields and actually excluded a few of them. If you're interested in that, you can always go, so I have the script, right? Because originally how I had this set up was I actually preferred to use the developer tool. So I should have that information here when I created this particular job. So these are the ones that I excluded. So here we go, canceled, flight delay min, flight delay type. Those fields are not useful for me, and I kind of excluded them in this result. And so what happens is that this machine learning job is going to use the remainder of fields. So it's just going to select the fields that are not useful, but the fields that are supported, right? Every other field that is supported. So some fields like text fields, those are not really useful for here, so those will be skipped for this particular job.
Elvis, can I jump in with a question?
Yeah.
Yeah. So this is from Joe Dorfman and on the chat. Question for classification.
Sure.
Can you use features based on text in documents, i.e. TF, IDF?
Yeah, so that's the thing. So currently we don't support it. That's a really common question that we get. So far, all you get is just doing classification by categorical and numerical values. You don't get the text fields yet, but that's something that's coming soon.
Okay, there's a second part to the question as well. How about other elements in PowerPoint, like if it has a bar chart or document metadata?
Sorry, I didn't get that one.
How about other elements in a PowerPoint, like if it has a bar chart or document metadata? Does that make sense?
I think it's more talking about, I think they'll need to provide more details to this one, but it's talking about whether maybe it's there's support for creating applications that look like more like a presentation or something like that, a visualization that look like a presentation. Yeah. I'm not sure. So maybe if you can get more details on that, I'll be able to answer.
Okay, Joe, if you could add some more.
Maybe rephrase it or something. Yeah. Okay.
Right. Feel free to unmute and just jump in, Joe, if you want to.
Yeah, there is another, I would like to add another question, which is, you mentioned that some of the algorithms that they're using behind the scene to do the classification for you. Is there any way to configure that and pick from a set of things, or you're sticking with what you're given, sort of?
Okay, so very, very good question, first of all. So far, we have been working on this one for so long now, but we have taken it in steps. So the first step that we wanted to ensure is like to give users the ability to do this out of the box without having to try too hard. And so what we did was just use AutoML, so just kind of use the algorithms that will be appropriate for this problem without you having to actually select it manually. And so what we offer today is, of course, you will not select the algorithm. You cannot select the algorithm, but you can select the hyperparameter. So the hyperparameter is something you can actually modify to your own use case. So you can use the APIs. So in this case, you really need to get familiar with the APIs, and you should be able to set up your own hyperparameters and these sort of things that you actually do with ML algorithms. Okay.
Okay, yeah, the question gates have opened. Just one more question here. So I think that was just answered actually, but what is the classification algorithm used behind the scene, and can it be changed? I think you just kind of answered that.
Yeah, so it's boosted trees. So these are the ones that are it's a bunch of forests. You can dig a forest. They actually make some decision, but it's an ensemble of them. So an ensemble of them, ensembling techniques are really good because you actually take the predictions of all these models, and you come up with a better prediction. So it's an average out of these predictions. But that stuff is going on behind the scenes. There's no way to actually modify it, as I think Jose was the one that's asking. So it leads back to the same answer.
Yeah, great. And just lastly, is the transform way also works for preparing data for basic visualization and not only for ML?
Definitely. Actually, that's the use case at the beginning. That was the use case. So to actually transform the data so that you can generate visualizations that show you the information that you want in the format that you want it. So that was one of the use cases. But transforms actually works really well for machine learning as well, because you need to transform the data in most use cases. You need to transform the data in a format that's suitable for that particular machine learning algorithm. So, if that work had to be done behind the scenes, then we had to do it for each of those algorithms. So we want to give that power to the user to establish and figure out what's the transformation that they need to put in place.
Another question. So we in the pipeline, right, that you mentioned now, using the classification or detecting the outliers, etc. Is there a way to hook some kind of event or trigger after the detection, let's say, right? Because you went through the data, we could identify, what the outliers were, etc. But we definitely want to do something with that afterwards, right?
Yes.
Is there any way to do that there?
Right. That's another really good question, and I was going to talk about that. So I'm glad you asked. So this one is something that we have. So we support this now. Like I think the last two versions of Elasticsearch or the Elasticstack actually support something called inference. So inference is this idea of training a model, right? Having those, so the parameters that were learned, the features that were learned, and all the characteristics of the model, having those stored in in an index. Like that's how we store everything in Elasticsearch, and use that information, on continuous data. So continuous data streams. The data that's coming in, you can now apply some kind of like processor tool, and you can do things like language detection. So if data is coming in multiple language, you can always apply this. So you would apply this as a concept called processor. So you can look at it in the documentation, and it shows you how to set it up. So you can do this, definitely apply what you have learned in this model on new data. So that was the whole idea of this. Yeah. That's definitely possible. All right, so let me just
move. I've got another question for you, but if you want to continue and we can come back to a question in a bit.
So so let me just finish it, because it's just gonna take like 2 minutes.
Yeah.
And then we can go to the questions, whatever questions we have here. Yeah. So I'm just gonna finish it here. I'm gonna go to data frame analytics, and the type I was talking about is this classification. So notice here, this is a new feature. So now we have like you have this confusion matrix. So when you're evaluating how this machine learning job is generalizing, that's the information you're going to use. It's already there in a neat visualization, so you can use the information. So here you can, how do you interpret this confusion matrix? So you can see here that we have the actual labels, so it's false and true. So if there's a delay, right, or there's not a delay, then there's a predicted label. So what the machine learning model is actually predicting. So you can actually look at this, interpret whether it's doing good. So you can see here there's obviously like true positives is like 70%, and then here like I think the false positive is 21. Now if that's something that's acceptable for you, you can always move forward, or you can experiment a little bit more, select different fields. So you go back, right? It's an iteration. You really need to reiterate to actually improve the model and experiment on it. That's why we have set up this way, and to make sure that you have a tool that you can always use for doing this reiteration. And machine learning in general, and always involves this process. You always need to be experimenting and making sure that you have a model that's optimal. So notice here that we have there are a couple of things as well that I didn't mention, but when you're training, right, so generally you're actually doing this on both the testing and training. So these results are for both testing and training, but it can actually exclude. So if you just want to look at what happened for the training data set, so this is how it's doing for the training data set. Generally, it's much better. It performs better because obviously it has access to labels. But in the testing case, right? So this is the held-up data set, and here is more like data that this particular model hasn't seen, right? So this one gives you how it's generalizing, and typically it will be lower. But the idea is to always have these values here. Go a little bit closer to what the validation to the training, so whatever the training was operating. So you want them as close as possible so that you get a really good model. So all this stuff is more like machine learning theory. Of course, you have to know about that to actually understand what's going on here, and that's why we have the classification and evaluation docs where you can actually check what those numbers mean. But this is what you generally use to get an idea of how this model is actually performing. Okay. All right, so I think that was it. That's the basic introduction. There's a lot to this as well that I couldn't go through today, but I hope you get the basic idea and how you will be able to use the ElasticStack for your machine learning use cases. So I think I could take some questions now.
Great, Elvis. Thank you very much. That was brilliant. Yeah, we've got two questions here. One from Ralph Brooks saying, assuming that the training of the model is happening against CPUs in your example, is that the case, or can Elasticsearch be configured to use GPUs for the training?
Okay, so really great question as well. It comes up a lot. So currently, as far as I know, we don't have support for GPUs, right? We don't have support. This is the reason, one of the reasons why you won't see this kind of deep learning models, right? You won't see support for these at the moment. But the team is figuring out a way, obviously, because when the Elasticsearch was created, it was created very not to support these use cases initially, and now we're moving into here, so we have a lot of things to consider if we want to support these different large scale models and models that use GPU and these sort of things. But at the moment, no. The short answer is no. And there's no way to be able to configure this unless you go into the code, you understand the code, and you figure out a way to actually develop the code for it. But at the moment, that's not supported out of the box.
Okay. And from Anastasios, can this predictive model be visible to external apps?
Yeah, definitely. So like I said, there's like an inference API. So the whole idea of Elasticsearch is to provide, so everything that you saw here, these results, everything is being stored. So in the form of an index. So that means that you can interact with this data from wherever you want. So you can actually build your own application to display this data and the results, whoever you want, because actually you're interacting with Elasticsearch, and Elasticsearch has that information stored somewhere. And you can reuse this, you can actually export. So we are spending more efforts on exporting these models and supporting, I think now you can even use it with scikit-learn. You can do this interoperability with scikit-learn. So there are different directions here. That's something we're working on. But yeah, definitely you can.
Excellent. Any more questions?
Yeah, another question is, do you have any info around performance for this, for the usage of these models, both
Yeah, so
at
that's
large scale? Yeah.
yeah. I wouldn't be able to comment on the actual like performance, but my recommendation is I do think like with bigger, of course, with bigger data sets, you would definitely have to like have you have to set up a couple of machine learning nodes, right? So all of this stuff that I was showing with the machine learning jobs, they're actually running on machines, right? Dedicated machines that use a bit of RAM and actually use some CPU as well. And these are things that you need to configure as you scale up the jobs, right? You have more data that you're using and you're performing this on large scale data.
So
So
it can be
definitely there is some
parallelized.
compute consideration here.
Okay.
But so one thing to add there is that the great thing of doing this in Elasticsearch is that Elasticsearch always have like so it has this compression algorithms available for you. So for us, it makes a lot of sense to actually support it because you can get access to these compression algorithms. So set up your machine learning job and store the results. And once you have stored the results, you can reuse it, and it's really easy to use because obviously Elasticsearch is pretty fast if you scale it well. So that's the other benefit as well. Mm-hmm. Any other questions?
I had a question. You said it could do language detection.
Yeah.
So how does it do that? So my earlier question was around using the text data for like TF-IDF analysis. How does it do the language detection without using a text field?
Yeah, so this one, so let me just search it here. You can actually language detection. This is a recent thing that we kind of supporting here, but it's using, so it's definitely using some kind of like algorithm, like so it's already built, out of the box, so you can actually use it. But I don't know like the specific details of what information it uses. It's probably using some TF-IDF. It's probably doing it. But that's really, really separate from all the other stuff that I was discussing. So this one is its own, its own little like algorithm that's there that supports this kind of detection capabilities. But I don't know the exact specifics of what it's using. So I'll probably have to do some more digging into that and see what's going on. Yeah.
Okay, thank you.
Sure. Any other questions?
Yeah, we have another question. Is the machine learning model subject to such evaluation metrics as cross-validation and hyperparameter tuning?
Yes, very good question. And the short answer, yes. So that's what's using behind the scenes. So it's using some Bayesian optimization technique to cross-validation, of course, to figure out what are the best hyperparameters. So it's doing this kind of, so that's how AutoML works, right? So it's always going to do this kind of search. And there are different like options available, and that's something you can configure. So you can configure which option you want, or you can even configure your own parameters. So you have both cases and both available for you. Yeah.
Okay, great. I'm conscious of time, so there's two more questions. So should we take two more?
Yeah, definitely.
Yeah. Could you elaborate more on the future NLP support?
Oh, that's the one. I like that question. It's not a machine learning presentation if it doesn't have that question, to be honest. So NLP, right? Really, really is trending. We're having conversations about what sort of NLP capabilities we want to have inside Elasticsearch and the Elastic Stack. So one of those capabilities is what's called semantic search. And semantic search is one of them because that's actually, it's a paradigm that moves away from the traditional TF-IDF. So TF-IDF is what you would use to do the normal search, right? So if you want to, for instance, search for, I don't know, say tweets related to a particular country. So what you would do is, if I want to search for US, I would search US, the actual term, and somehow the model learns, not the model learns, but the Elasticsearch can determine, because the search engine determines what are the documents that are most related based on the term that I've searched. But this is an exact search. So what I would want is to have some kind of semantic capability to do the search, meaning that if I search for US, a document that's being returned doesn't necessarily have to have the word US, but something that's related to US. So that's an amazing feature. I think that's going to come pretty soon because there's like a team working behind that. that particular feature. And so for NLP in general, like classification, being able to work directly on text as well. So like the gentleman asked today whether there was like using some kind of TF-IDF. That's something that we generally want to support as well. So being able to set up some kind of text classification, but it's already being done already. So for language detection, which is a common use case, so I think they want to generalize it and have it available like this interface as well eventually. So classification, language models. How do we support the use of language models? Because these are things that are very common today, and be able to do all sorts of NLP tasks, like not only sentiment classification, but other tasks like question answering and these sort of things. So we see a lot of use cases and different NLP use cases, and that's something that we want to support like inside Elasticsearch natively. So definitely expect something to happen in the future.
Excellent. Okay, so we'll take the last question now. Are there Python-based APIs provided for Elastic's ML?
Oh, there is a wonderful API, and we actually hired a few people to work on the. So it's Elasticsearch, and there's an agent, right? And I think it's called Elasticsearch DSL. So I think there are two versions, but Elasticsearch DSL is the one that we're maintaining. And this allows you, of course, it gives you all sorts of features to interact with Elasticsearch directly. But then there's an even more interesting one, which is Elasticsearch. I think it's called ELAND, E-L-E-N-D. And this one is the one that's we are working on currently to be able to like support interoperability with other different like machine learning tools and toolkits. So like scikit-learn and these things that you can combine together. So you can have Elasticsearch as your search engine, doing the transformation for your data, because it's scalable. And then eventually, I think it's here. So check out this one. This is pretty interesting, and it's a new thing, of course. And you can set up your notebooks, because this is what data scientists use a lot today. And just use, so this one combines the Elasticsearch DSL DSL client, a Python client, and then it does like data frame analytics, all this stuff, aggregation of the data, and it does this really in a scalable way. So I think this makes a lot of sense, and then they're constantly updating this. So check that out.
Wonderful.
Yeah.
Elvis, thank you so much for your time. It would be great if you could turn your camera on to wave us farewell.
If I can figure it out. Let me see. Okay.
I hope everyone. There you go. Perfect. Great. Well, thanks everyone. Thanks Elvis again for your time. Really appreciate it. And as I say, we'll upload the video on our YouTube channel in a few days. And yeah, keep online and look out for more events to come from us. And
thank you very much
as well. Thanks, Elvis.
Thank you.
Bye, everyone.
Thank you, everyone.